seminar we'll be talking about how we store data within a computer. And to start off with, we have a bit. A bit is the most fundamental and tiniest data storage type within a computer. So a bit, a single bit, can only store a single binary digit, i.e. it can store a 1 or a 0. Now, we represent that 1 and 0 generally with two different voltage levels. A high voltage level, which might be 5 volts or 3.3 volts, depending on the voltage levels we're dealing with, and a low voltage level, which is 0 volts generally. So our next data type that we'll be looking at is a byte. And a byte is simply a collection of 8 bits. So we join 8 bits together and we create a byte. And now we have 8 bits all together, we can store larger numbers. So if we say 2 to the power of 8, it equals 256. That means that we can store the numbers from 0 through to 255. We'll talk about all the conversions of decimal and binary in a moment. But you've probably started to realize that computers see numbers a little differently to how humans see them and how they think about them and store them. Humans use a base 10 number system, and if you look at human hands, we have 10 fingers, we have 10 symbols that we can use to store numbers, so it becomes very natural for us to store numbers this way. If we're thinking strictly about how we store decimal numbers, we'd be counting from 0 through to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, then we have binary. So binary is a base 2 number system, and we can only store 2 numbers, either 0 or 1. That's what we use within the computer. And something we often also use in the computer is hexadecimal. Now, hexadecimal is a base 16 number system, and is a nice way to represent clumps of binary numbers. It's a bit of a nuisance for us to see a whole series of zeros and ones as a human. But if we clump them together, we can very quickly and easily convert them to a hexadecimal number. So we have the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, like we did in decimal. And we also have the numbers A, B, C, D, E, and F to represent the numbers 10, 11, 12, 13, 14, and 15 respectively.
Now in your maths subjects, you'll be performing conversions between binary and hexadecimal and decimal numbers. We're not going to concern ourselves with that for the moment. Suffice to say that if we need to do so, and we may need to do so at times in the labs, we won't do it mathematically. The Windows calculator has a nice built-in function, particularly if we switch it to programmer mode, where we can choose the hexadecimal, octal, which is a base 8 number system, and binary number system representation. Now these are also aligned to nice shortcut keys, F5 through to F8. So if we press F5, we'll convert the number to a hex, and F6 to a decimal, and so on. So just briefly, we'll look at the notation that we use for denoting whether a particular number is a binary, or a hexadecimal, or a decimal. For binary, it obviously only consists of 1 and zeros, and we end it either with a subscript 2 or with a lowercase b, indicating it's a binary number. For decimal, we might use a subscript 10, or we don't need to put anything there. Any number that doesn't have a subscript or any other modifiers on there, we assume it's a decimal number. And for hexadecimal, we have a few different options. We could do a subscript 16, so saying it's base 16. We can end it in a H, or most commonly when we're programming, we'll write 0x and then the hexadecimal number, the 0x denoting that it's a hexadecimal number. Now obviously when we're writing code, we can't put in subscripts and things like that, so we don't use a subscript 2, 10 and 16 method. We generally go for having a b or a 0x or a h at the end of our hexadecimal number. It's also useful for us to be able to manipulate individual bits in a particular byte or some sort of a data structure. So let's say we've got a byte, we've got 8 bits, and we want to either work out whether a particular bit is high or low, irrespective of what all the rest of the bits are, or we want to set a particular bit to be high or low. Well, we have a nice little function in our Arduino language that allows us to do both of these things. So we have the bit read command, and bit read we'll return a value that corresponds to whether that bit is high or low. So we specify in the first argument in our function, where x is the actual number that we're interested in, probably an integer or a byte or something like that. And then the second argument allows us to choose which bit that we're interested in. So if we put 0 in there, it'll give us the least significant bit, or LSB. If we put 1 in there, it'll give us the second least significant bit, so bit 1. And that will return a value either 1 or 0, depending whether there's a 1 or a 0 in that position in the data structure in a number. Now we might want to set those numbers, and to do that we use the bit write function. So once again we specify the number. It might be a byte, it might be an integer or something like that. We then specify the bit that we're interested in. So we might specify 0 if it's the least significant bit. We might specify 15 if it's the most significant bit of an integer, for example. And then we specify whether it's going to be high or low. So then we specify 1 or 0, and that will write the 1 or 0 into that particular bit.